Today we're talking about polynomials, and first we'll talk about in this section how to add and subtract them. But we have some vocabulary to talk about first. So a monomial is a number, a variable, or the product of a number and one or more variables with whole number exponents. So let's just talk a little bit about that. So a number. So we would know that something like the number 7, that's a number. A variable, some sort of a variable, or the product of a number and one or more variables. So something like 3xy with whole number exponents. So what that means is no fractional exponents. So none of those rational ones we talked about. No negative. Or no variable exponents. Okay, so you can't have any fractional, negative, or variable exponents. Then we talk about the degree of a monomial. This is the sum of the exponents of the variables in the monomial. It doesn't matter if they're different variables, the sum of the exponents. The degree of a non-zero constant term, like up above when I said the number 7, is always 0. And the constant 0 doesn't have a degree. So let's just kind of run through this chart. So here are some monomial examples. The number 10, well, that is a non-zero constant. Any constant is the degree of 0. On the second one, 3x. So I do the sum of the variables. Well, 3 is a 0. X, there's really a 1 sitting there. So if I add those two together, it's the degree of a 1. On the next one, the 1/2 is a 0. The a does have a 1 in there. And then 2 on the b means that I would have a 3 for my degree. And on the last one, it's only the 5th, so that would be the degree of 5. So these are not monomials. So we want to just kind of make sure we understand why. All right? Monomials are a product. So this is not, because this is a sum. Don't get caught with that because we're adding 5 and x. This is not a monomial. That needs to be the product. On the next one, monomials we set up above don't have negative exponents or really variables in the denominator. This is really n to the -1 power. So we said that our exponents can't be negative. On the next one, we can't have variables as our exponents. Now again, we can't, not necessarily, we can still do things with these, we just can't call them monomials. And the last one again, we can't have a negative. Okay, so we can't have negative exponents. So let's just look at some more fuller examples. Find the degree of each monomial. Well, if I look at the first one again, 5x squared. The 5 really has a 0, so we would just be adding, we would get 2. On the next one, the -1/2 is a 0. There's a little 1 sitting in there for the x, even though we don't see it. So this is the 4th degree. On the next one, the 3 and the 3 make a 6th degree. And on the last one, any negative constant or any constant, would be a 0, except if it was 0, and then we said that it just doesn't have a degree. So now we want to talk about this next term called a polynomial. So a polynomial is a monomial or sum of monomials. So it's kind of like the general term. It means many of monomials. So a monomial is a polynomial, but we also will get the sum of other monomials to create different polynomials. So each monomial is called a term of the polynomial. A polynomial with two terms is a binomial. A polynomial with three terms is a trinomial. So hopefully we know those two prefixes, bi meaning two, tri meaning three. And then so here's some examples. So this is a monomial. This is also a monomial. When we are adding them, it becomes a polynomial, and there are two terms. So the adding or subtracting would separate out my terms. So in this case, I have monomial plus another monomial plus another monomial. That makes it a trinomial. So this is where we have to think the difference here. So the degree of the polynomials is different than the monomials. It is the greatest degree of the term. So a polynomial in one variable is in standard form when the exponents of the terms decrease from left to right. And we're going to show some examples here. When you write a polynomial in standard form, the coefficient of the first term is called the leading coefficient. So what does all that mean? So when we did the degrees of the monomials, we were trying to figure out the adding of the sum of the exponents. Well, in the polynomial, the degree of the polynomial is the highest one from all of them. So you figure out each monomial, and then you would figure out the degree of the polynomial. And we're going to see some in a little bit. So let's first do writing a polynomial in standard form. So if I see 15x minus x to the third plus 3 in standard form, what I would first do is look at my separate monomials to figure out which one has the highest degree. So the highest degree, if I look at these, 15x is to the first degree. X to the third is to the third degree. And then if I look at the last one, that's the 0 degree. So to write these in order, I would be putting my highest one first. So negative x to the third, that's the highest degree, plus 15x plus 3. So the degree of the polynomial would be 3, because of all the monomials, it is the highest one, so it would be 3 for the entire polynomial. And our leading coefficient is the negative 1 that's out in front of the whole polynomial. So next we're going to be writing these polynomials, classifying their degrees, and telling us what type of polynomial we have. So for the first one, the standard form. Well, there really isn't anything different to write, because there's only one term. The degree of this polynomial, again, as a monomial, this is to the fourth degree. And the type of polynomial, this would be a monomial because there's only one term. So next we're going to talk about the next 4 plus 5x squared. So in standard form, we would need to rewrite this a little bit, 5x squared plus the 4, because when I look at the degrees of those terms, the 4 is a 0 degree, and the 5x squared is a 2 degree. So the 2 degree would come first. The degree of the polynomial in general, I'm going to just take the highest degree of one of the terms, so the 2. And the type is 2 terms, tells me that this is a binomial. There are 2 terms. Then the next one, q to the 5th plus 8q would put this into standard form. The degree of the polynomial is to the 5th degree because the 8q is only a 1 degree. The q to the 5th is a 5th degree, and we would take the highest. Do not add those 2 together to make it the 6th degree. Once you have the pluses or minuses in between the terms, you would just take the highest degree. And then this is also a binomial. All right, so now adding polynomials. You basically are just adding like terms. So remember, when you're adding like terms, they have to have the exact same ending. Okay, so finding the sum in examples 4 here. So I can add x cubes to other x cubes. So I would now have 3x cubed. I can add x squares to other x squares. That would give me negative 3x squared. I don't have any single just x's in the other one, so that's just going to become that. And then I'm going to have just regular constants at the end. So that would be my answer to the first one. I just put those underlines for me to help see which ones belong to which. So the single underlines belong to the third, the second underlines belong to those x squareds, etc. On the next one, I see x squareds to give me 4x squared. I see x being added to 4x, which gives me 5x. I see a negative 6 being added to a 10, which gives me a 4. Subtracting polynomials, and you have to be careful on this one. So be careful of that minus sign. So again, same idea though, I'm looking at my like terms. So I have 4x squared minus negative 2n squared, which really becomes 6n squared. You got to be careful, you are subtracting a negative. Then I look at the n's. I only have one of them, but notice that on the inside it's a plus 2n, but it's minus 2n because of that negative out in front. And then I have the constants 5 minus negative 4, which really becomes 9. Be really careful on the subtraction ones. On the next one, 4x squared minus 3x squared leaves me with x squared. Negative 3x minus negative x. Remember that becomes plus positive x, so negative 2x. And then 5 with a negative 8, but it's 5 minus negative 8, which is 13. Be really careful on the subtraction ones. It's really easy to kind of go quickly through it and forget that subtracting on the outside of the parentheses goes through everything first. Then we've got one more to go. We have our word problem here. So we'll have a penny Trying to see if it has this ever. Nope, it doesn't. Okay. So we have a penny that's being thrown straight down from the height of 200 feet. At the same time, a paintbrush is dropped from a height of 100 feet. The polynomials represent the height of the feet after t seconds. So we are given these two polynomials to represent the distance traveled over t time. So we want to do a couple of things. So I don't even have the directions here. So let me pause for a second just to give you the words. So we want to write a polynomial that represents the difference between the two at t seconds. So difference, subtraction. So basically this is just asking us to subtract. So on the previous examples, I did those kind of horizontally. I just kind of left them as they were. This is kind of set up to almost be a good vertical one to practice on. So if I just drew a line here, just to kind of just do a little bit of a shortcut, thinking subtract. This is another one you got to be careful of. So we're kind of thinking of this as subtracting the first one and the second one. So if I do 16t squared, negative 16t squared minus negative 16t squared, that becomes negative 16t squared plus positive 16t squared. So that means that basically eliminates itself. Okay. Then if I do negative 40t minus nothing, then that would leave me negative 40t. And if I do 200 minus 100, I would get plus 100. So just to write a polynomial that's representing the difference between the two at t seconds would just be this, where you would kind of be writing out how the difference of these two polynomials would be. And then we can take a look at some of these things, and we'll see more of this as the next few lessons come along. But this negative 16 is kind of telling us the gravitational pull. So we said we were dropping this thing, and gravity's going to pull it down. That's really where this negative 16 is coming in. This number at the end, if you think about it, if t was 0, meaning right before we dropped it, this is our initial value, which would be our y-intercept if I was graphing this. So t would be seconds, or the x value. 200 feet is the first one. This one, the same thing. If this was a 0, we would be starting at 100 feet for this one. So what this is saying in here, once I found the difference, is at 0 seconds, we are 100 feet apart, which makes sense here because these two are 100 feet apart. This negative 40 this time is basically like a slope, in a sense that for every second that happens, we are changing by 40 feet as we go. So we'll look more into these polynomials and where the different numbers and what they are meaning as we go. But that is the first part of Chapter 7, polynomials, dealing with the degrees, also how to add and subtract them. And good luck with things. If you have any kind of questions, please feel free to ask as soon as you need me.